Hello everyone, Vladimir is here, and in the previous lesson of multi-platform game development, we've made a simple background for a game. Today we're going to implement the tiles where our player is going to walk, or rather tile bases, just to show how our player is going to dodge the attacks, and we'll also display the player sprite, just to see how it looks, just to get the feel out of it. And without further ado, let's just look what we had from the previous lesson. Let me switch to our desktop, and well, let's launch the game. As you see, it's just a background. So let me just prepare new assets. First we need the base where the player is going to be standing. I'll just redraw the one. I'll just make a new image, 16 in width and 2 in height. It's a very small image. Delete everything and just draw 2 lines. I usually just zoom in to be able to draw things better, and then let's save it in our base assets folder as base PNG. I'm going to replace the one. I was actually practicing, now you know my secret. And after that, well, we have the base, but what do we do with the hero? And to fix that, we're actually going to take one from the tile set that we have already used. We'll take the characters PNG file, download to our computer, then open it in our paint.net. I'm just going to drag it to my paint.net. You see, there are a lot of characters here, but I don't need that many. And for the tutorial purposes, I'm just gonna cut only one up. Maybe this one, because let's see, it should be 16 by 16. Yep, you can see the size of your selection on the left bottom corner of paint.net if you are using it, and which is very convenient. I'm going to create the new image, paste our character, and save it as player PNG. Great, now we have the assets, but as usual we need to access them from the game somehow. Let's go back to our resources, and the same way as we have introduced our ground and wall tiles, texture regions, we're going to introduce our player and the base texture regions. Same things, load them the same way as we do ground and wall. Player equals game sprites, find region, player. Same way, really, just change the names. After we do this, well, technically we can draw them, but where are we gonna draw them? And to solve this issue, we need it. I usually use the extra class called, I'm calling it size evaluator. The thing is, we have the same problem as we had with the background. We really don't know the size of the screen that we are going to get. So my idea, since we have a one screen game, we're just going to use the center of the screen, center of the stage, as our pivot point, and we're going to base everything according to that. So in our graph package, let's create a new class and call it size evaluator. Yes, add it to my repository. I think the good way how we can initialize it, we'll need 4 variables. One would be the stage. I'm going to make it a private variable stage called the measured stage. Make sure to import Libgdx stage by pressing Alt-Enter over the stage. After that, apart from the stage that we're going to measure, because we're simply, as we talked at the first lesson, we're going to take the left half for the tiles for our field where player can walk, and the right half for the monster. Right now let's focus on the left half. So we have the stage, which we will take the center and work with the left half. We actually also need the resources because, hey, we need to know the tile size so we could measure everything properly. So let me do this by simply introducing our resources. variable. It will point out to our game resource class, how you have probably figured out already. And we also, like we talked before, we're going to have 4x4 field. So, but this is a flexible requirement. It might change any day. Whenever we playtest the game, we still don't know how it goes. So let's make it as easy to change as possible. I'm going to introduce two private variables, which one of them I will call max style base x. Let's make it final, so it's not going to get changed during the runtime. Max style base y. It will indicate our maximal possible coordinates, which we will use. Let's create the constructor, public size evaluator. We'll need to pass all of these parameters to assign the proper values to them. Resources, base x, max base y, and in the constructor we simply assign those variables. The thing is, I'll describe how we're going to use those coordinates of 4x4 field. I think we're just going to use the x coordinates are going to be from left to right, simple, same as the screen, like from 0 to 3. 0 is the leftmost and 3 is the rightmost, and y is going to be from 0 to 3 too, but 0 at the bottom and 3 at the top, essentially, or rather max style base y, max 0 at the bottom, and this size evaluator is going to give us the coordinates of every base that we are going to draw. And to do that, I think we need to introduce two functions. One will be like get base screen x or something like that, which will return the coordinates of our bases. Public float get base screen x. We will pass the coordinate of our base from 1 to 3 and get the screen coordinates, so we will be able to draw it smoothly. Let's call the parameter base x, and the function shouldn't be very complicated. I mean, we return the value. We just take the middle of our measured stage, right? We just split the total width of the stage by 2, and then we subtract the tile size multiplied by the max tile base x plus 1 minus base x itself. What does the second part mean? Basically, we're taking the tile size, which is 16 pixels, and we are multiplying it by the amount of tiles to the left of the center of the screen. Like, if we are passing the base x equal to 0, obviously we need to draw it on the left side of the screen. So we need to take the maximum tiles that there possibly can be and subtract them from the middle of the screen, and that way we're getting this this value. We'll see it as we run the game. It's often an empirical process, meaning you have to experiment, but you also need to understand what's going on. So I suggest, if you cannot understand what it is, start by removing some parts of the equation, like remove the whole part, just return the stage center at first, and after that experiment and experiment. And the same thing we need to do with y. Base screen y we'll passing the base y coordinate, and we're going to return the almost similar thing. Measure stage, we take the height of our stage, we subtract the resources, tile size, no, actually this one will be different, because you see, when we calculate the x coordinates, we need the field to be on the leftmost part of the screen. In case of our y coordinates, we need to our bases be right at the center of the screen. Therefore, I'm going to use max tile base y plus 1, but I'm going to divide it by 2. And this will ensure that our coordinates will be somewhat centered. Well, to get picture is worth 1,000 words. So let me do the initial impression of what we're going to get, and then you'll understand by yourself what I'm talking about. So in our game screen class, let's introduce the variables that indicate the base amount. Public static final int or rather our final coordinates on x and y scale. Both are 3. They're from 0 to 3. And let's just actually introduce this separate function which will draw our bases. Void draw bases, and there we just take our batch, we initialize our batch, and then we stop our batch, which will send the commands to the GUI. Batch is responsible for drawing the sprites. So the thing is, you initialize the drawing process, begin, you draw all the things that you want, and then you finalize it with end. After you run the end command, actually all those things that you have drawn are sent to the graphic card. That's why it's called batch. They're sent in batches to improve the performance often. So what we need to do is we need to go from x equal 0 to x equal or lesser than maximum coordinate on x scale, and then we increase it, and do the same thing for y. I'll explain it in a bit, just bear with me. And we should draw our base coordinate, base at the coordinates that our size evaluator, we need the size evaluator. The size evaluator is going to give us. Let's declare our size evaluator, private size evaluator, so we will be able to use it. Initialize it. Pass him the game stage that we have recently created. Pass him our game resources and our new constants. After that, we can use it in our draw bases function. Let's just get base screen x, and so the idea behind the cycle is that we are drawing max base x plus 1 columns of our bases, and each column consists of max base y plus 1 elements. So it will be 4x4 in our case. As usual, you can experiment what's going on. If we, for example, comment out the cycle, you'll see that, and switch the x by 0, you'll see what's going on. Let me show you, just for the science. Okay, nothing happens. Why is nothing happening? Because I'm not calling the draw bases command. I should draw the bases right after our background is drawn. Layering is important. Call the draw bases in our render function. See, I have the first column of our bases. Now we just need to draw the remaining 3 columns. And that's why our cycle is going to help us. We're going from the column 0 to column 1 to column 2 to column 3. And we draw every one of them, or every row. For example, we're drawing the row 0 when y is 0, then we're drawing the row 1 when y is 1, etc, etc. It's not very complicated function, but if you have any questions, I'm always open to this, you can always ask. So what do we have here? We have our bases drawn, but you know, it already seems somewhat off. This is because, well, they're so close together, you cannot distinguish the difference between them. They just seem like the mixed roads, and it just doesn't look very cool. Let's introduce some sort of a margin in them. We'll go to our size evaluator class. Let's add some static final variable, which is base margin. This will indicate how much extra distance are there between our drawings, and we're going to use it when we evaluate the size. Wait, wrong screen where I introduced it. Sorry. Go to size evaluator Java class, introduce our constant there, and after you have introduced it, adjust our get bases. As you see, the second part is multiplication, meaning that essentially our tile size, which is the distance between bases, is multiplied by the base coordinate that we want. So if we want to increase the distance, we increase the value of this parameter, which is tile size. We just add our base margin to it, and as we add it, we'll be able to see the result soon. We've added the base margin to the equation, nothing more. Make sure to put the brackets there, otherwise, like, the order operations matters, right? And as we run the game, you see, it just feels much better. Now we can at least distinguish the bases from one another. If you're not okay with this, if you think the distance is, well, too small, you can adjust it by adjusting the base margin. For example, if I like the distance 3, lucky number, yep, well, you get something like this, which might look a bit better. Right, so let us try to draw the player as a conclusion of this lesson. I'm going back to game screen, and as a temporary measure, just to get the instant gratification, like, wow, I did something and I'm making progress, let's call the batch in our draw bases function, let's call batch draw and draw our game player, you know, just for fun. We're going to remove this part of the code, but just to show you what we're on, I'm going to draw it here. Let's get the base where we want our player. For example, we want our base number 1. I almost said second base, man. No, don't do this. And the same thing with base Y. And you see we have a character. It overlaps the base. So to fix it temporarily, we'll just add our base margin actually. And the character will be drawn above the base. But you see, as soon as the character is drawn, it seems way off, because it just feels like the character is stuck between the two tiles. Like he's trapped in a prison, like only this prison may be existential prison, I don't know, existential pixel prison, and he's suffering. You can already see the suffering in his eyes. To fix this, we are going to get rid of this mistake. It's not a good idea to make tiles of the size, like visible tiles or some visible marks, as the size as big as the player. So we're going to reduce the y coordinates of our bases. We can try reducing them by maybe 1/3 and seeing how it goes. Let's go back to our size evaluator class, and in our get base screen y function, we'll just going to multiply what we have here by 2 and divide by 3. Essentially just 65%, 66%. I'm going to delete this. And let's see what changes. And this is, you see, this is a good idea because even though we change the base coordinate, we don't need to change anything on the side of game screen. Our size evaluator just returns the proper coordinates. And I do think that this, what we have here, is a bit better. Let me scale it. You see, now the character just stands properly and, well, properly is a strong word, but you can see that something is happening. He's not stuck between things. He's just there chilling and doing his job. And I think this concludes our lesson. Let me just commit the changes so you will be able to see them eventually. Introducing, no, just check the status. We have added files. And we are going to commit them. Introducing the bases where player stands. Added basic player base sprites. After our commit is done, we push it to our server, which is the GitHub. And all done. Thank you for watching. I'll see you guys in the next video where we're actually going to try to control our player and work with the game logic. Once again, thank you and see you soon. Vladimir is out.